Thank you, and hello everyone. Today, me and Bill Ben Haim will talk about Azure Active Directory and some attack scenarios abusing it. But before we start, who are we? So, my name is Ulianitzky. I'm the head of research at XM Cyber, and with me we have Bill Ben Haim, which is a senior security researcher in the team. We have a lot of experience in penetration testing, red teaming, and in the research area. When we were young, Bill Ben Haim and I have been practiced together in judo and represented the Israeli national team in judo, and he used to beat me actually. These days we do a lot of bug bounties, and we actually really love it. So let's begin. Our agenda for today starts with some Azure fundamentals, because before we understand how to attack Azure, we need to understand some theory about how it works. We will talk about some resource manager fundamentals, and then we'll continue to Azure Active Directory fundamentals. We will then understand the relationship between them and how, in the point of view of the attacker, we can gain the initial foothold. Then Bill will show you some attack scenarios in the Azure environment itself, and we will continue with best practices in order to secure the environment. We will finish with XMGoat, which is a new open source tool we are releasing today, and I will talk further about it during the session. So let's begin. As everyone probably knows, Azure provides many infrastructure services. Let's better understand them. The Resource Manager is the service that manages all the resources within the Azure environment. And actually, the Resource Manager provides 4 different levels of scopes. Let's better understand them. The first scope is called the resources scope. And probably, as the name suggests, it represents a resource that have been created within the environment itself. We have many types of resources. We have virtual machines, storage accounts, databases, and many more. The next layer is the resource group. And the resource group is a container of different resources. Whenever we create a new resource, we must define which resource group will hold it. Next, we have subscriptions. Let's see how Microsoft defines a subscription. A subscription is an agreement with Microsoft to use one or more Microsoft Cloud platforms or services for which charges occur based on either a per-user license fee or on cloud-based resource consumption. So what does it actually mean? When we are going to get the bills for the resources that have been created in the environment itself, it's going to be related per subscription. The last layer is the management group. And in general, a management group is just another layer in the subscription layer of the resource manager. Usually, we create different management groups in order to manage the multiple subscriptions or other management groups. By default, when we create a new Azure Active Directory tenant, behind the scene, the root management group is created by default. Perfect. Let's see an example of architecture. In this example, we have the corporate IT, and we can see that the corporate IT have 3 different environments: the production environment, the development environment, and the QA environment. Each one of them is being represented as a management group. Next, we have some sub-environments. Each one of them is being represented as a subscription. And last, for each environment, we have different applications. Each application is being represented as a resource group, and all the resources that we are creating in each resource group is relevant for that application. Perfect. So we finished with the different layers. Let's better understand the permission model related to the resource manager itself. And when we talk about the permission model in Azure, we have 3 different types of objects. We have the scope object, the role definition object, and a role assignment object. Let's better understand them. Role definition is a set of allowed and not allowed permissions. We have 2 different types of role definitions. We have built-in definitions, which are being created and managed by Azure itself, and we have custom definitions, which are created by us and managed by us. Let's see the example. In this example, we have the pre-built role definition with the name of contributor. we can see in the action sections that we have a wildcard, which means that inside this definition, all the permissions are allowed. In the not action sections, we see 3 different permissions related to authorizations. So when we take the actions and the not actions together, it means that this role definition gives the user that assigned to it all the permissions except those 3. In addition, we have the assignable scope. And we can see that we can assign this role definition on any scope that we want. And we will better understand it now. So what are the scopes? If you remember, we talked about the different layers within the resource manager. So each one of those layers represent a different scope. And actually, access is inherited in a parent-child relationship. So when we assign permission on the management group, it's going to propagate all down the way to the subscriptions, resource groups, and finally the resources that are within that scope. The last object, and the most important one, is called a role assignment. And let's see how Microsoft defines it. A role assignment is the process of attaching a role definition to a user, group, service principal, or managed identity at a particular scope for the purpose of granting access. And as they define it, this is what it represents. It ties all the dots together and assigns the permission to specific users on a specific scope. Let's see an example. In this example, we have a role assignment. This role assignment is going to be applied to the marketing group. And for the marketing group, we're going to assign the contributor role definition, and it's going to be on the former sales resource group. So what does it mean? That every member inside the marketing group going to receive the contributor role definition on the former sales resource group and all the resources that have been created within that resource group. Perfect. So we finished with everything that is related to the infrastructure. Let's talk about some Azure Active Directory fundamentals. And actually, if we will try to read on the web about some documentation provided by Microsoft, we will see a lot of times a lot of references to principles. So let's understand what types of principles we have inside Azure. The first one, and the most common one, is users. And usually, users supposed to represent a human being which is going to use the tenant itself. We have different types of principles. We have cloud or synced users. Cloud users are users that have been created inside the tenant itself. And synced users are users that have been synced from an on-prem environment to the cloud. In addition, we have member or guest, which is pretty similar. We have members that have been created in the tenant itself, and we have guests who have been invited to the tenant. The next principle is groups. And probably as everyone knows, and the name suggests, a group is just a set of members. Each group have the owners and their members, and the owners of the group can actually manage and control everything related to the group. They can change the membership of the group and so on. In addition, we have different types of groups. We have assigned groups, which means that a user needs to manually assign members to the group, and we have dynamic groups, which means that a user is going to be related to a group based on a specific condition. The next principle, and the most confusing one, is application and service principles. Applications, or in Microsoft terminology, app registrations, represent an application that have been created in the tenant. We have 2 types of applications. We have a single tenant application, which means that the application can be used only in this tenant, and we have multi-tenant application, which means that the application can be shared across different tenants. In addition, whenever we create an application, a single tenant application, behind the scene, a service principal is going to be created which represents that application. When we create a multi-tenant application from tenant A and we want to share it to tenant B, a service principal on tenant B is going to be created and it is going to represent that application. And whenever we assign any resource manager permissions two applications, we are actually assigning the permission to the service principal that manage that application. As I said, application have permissions, and we have two types of permissions. We have delegated permissions, which means that the application requires a signed-in user through that application, and we have application permissions, which doesn't require a signed-in user. Because applications have permission, they need to gain access to different APIs. In order to authenticate, we have two different types of passwords. We have secrets, which is similar to a password, and we have certificates. Each one of them can be used in order to authenticate to different services provided by Microsoft. The last principle is called managed identity. And actually, behind the scene, a managed identity is a service principal with a unique type. When we want to give access between two different services within Azure, for example, a virtual machine that would like to ask a specific blob from a storage account, we can't do it directly. We must attach an identity to the virtual machine, give the relevant permissions to the identity, and then the virtual machine is going to use the identity to perform the operation on her behalf. Perfect. So let's talk for a bit about the permission model within Azure Active Directory. And actually, the permission model is really similar to the one in the Resource Manager. We have role definitions, and we have two types of definitions. We have the pre-built definitions that again are being managed by Microsoft themselves. In this example, I marked the application administrator, which is a pre-built role definition, and we have custom role definitions. And as I speak, they are not really mature, so I won't continue to talk about them during this session. Perfect. So we finished with all the fundamentals. We can start talking about the relationship between them. We can see in this example that the Azure Active Directory tenant sits right above the root management group. And just for recap, the root management group is the default management group that is being created when we are creating a new tenant. So whenever we assign permission to principals within the Resource Manager, we are assigning permissions to the principals that we are creating in the Azure Active Directory tenant itself. Last year, Sean Metcalf showed a nice attack vector which abuses an elevation feature provided by Microsoft. So, if we compromise a global administrator user, we can use this feature, which behind the scene going to create a new role assignment on the root management group and give for the same user the user access administrator role definition. And using this role, we can modify any role assignment that we would like, and because it's on the root management group, we can do it on any scope that we want. So basically it means game over. The next object is devices. And device actually registers a device that is being registered to the tenant itself. We have three different types of devices. We have an Azure AD registration device, which means a device of a self-employee or something like that. We have Azure AD join device, which represents a device that is joined to the Azure Active Directory tenant. And we have hybrid Azure AD join device, which represents a device that is joined both to the Azure Active Directory tenant and to an on-prem domain. In addition, we have Microsoft Intune, which is an MDM solution used to manage those devices. Last year, SpectreOps showed a nice attack vector which abuses global administrator and Intune administrator users and allow them to execute code from the cloud environment back to the devices that are being managed on the on-premise environment. Later on this talk, Bill will show you a similar attack vector which abuses a different with the use of a different technique. Perfect. If you remember, we talked in the beginning for a short time about AD Connect. So what it actually? AD Connect is a tool provided by Microsoft that allows us to synchronize our on-prem environment to the cloud. For example, it synchronizes all the users and groups that we've been created in the on-premise domain to the cloud. In addition, it provides multiple features. For example, we can authenticate as those users to the tenant itself. And actually, there are 3 different types of authentication. We have password asynchronization, which means that the hashes of the password related to the on-prem users are being synced to the cloud. We have pass-through authentication, which means that whenever the on-prem user tries to authenticate to the tenant, his credentials are going to be verified against the on-prem domain controller. And we have federation integration, which means that the authentication is going to be used with ADFS. Perfect. Perfect. So we talked a lot about different fundamentals, both the Azure Active Directory and the Resource Manager. But one of the interesting questions is how we can gain the initial foothold. And actually, there are multiple ways to achieve it. We can use phishing, brute force, or even password spraying attacks in order to compromise a specific user. In addition, if we have been compromising a specific machine in the on-prem environment, we can try to look on default paths or the certificate store for credentials related to users or different applications. In addition, we can abuse AD Connect, and we will see a demo about it just in a minute. And we can abuse different SSO features, such as PRT tokens or AD Connect seamless single sign-on. So we have implemented an attack which is going to exploit the pass-through authentication of AD Connect and showed by Adam Chester. And during this attack, we're going to perform a DLL injection into the Azure AD Authentication Agent service inside the on-prem machine. We're going to hook the logon user W win API using a trampoline function, and we will backdoor any user that will try to log in with the ACT password phrase. In addition, we're going to log every successful authentication request into a local file. This might help us if a real user tries to authenticate to the tenant. We can harvest his credentials in order to perform additional lateral movement in the on-prem environment. So let's see it in action. Okay, so this is a compromised on-prem machine. And currently, I'm going to show you the users in this tenant. We can see many users here, and one of them is an on-prem user, which currently we don't know his password. Next, I'm going to show you the source code of the hooked function. And we can see the trampoline itself, the hooked function, and a very interesting if statement that says, if the user used the password ACT, we're going to return true, which means authenticate him without even knowing his password. In addition, if a normal user wants to use the tenant itself, we're going to forward the same authentication to the domain controller in order to not interrupt the day-to-day business. Now, I'm going to perform the injection into the process that is managing the authentication for the AD Connect itself. And we injected our DLL. Now, we are going to try to authenticate with the on-prem user, which once again, no one knows his password. And if you remember our backdoor, whenever we type the ACT password, we're going to successfully authenticate. So let's see it in action. And bam, we're authenticated as the user without even knowing his password, and we only compromised an on-prem machine. Perfect. So thank you. Bill, the stage is yours.
Thank you, Tzur, for that great demo. Okay, so before talking about any attack vectors, we need to first understand the internal reconnaissance phase, which will be crucial for the next steps. From the attacker's perspective, we want to gather as much information possible on both the resource manager and the Azure AD environment in order to gather and search for potential vulnerabilities and misconfigurations in the current cloud setups. We will enumerate the following principles: groups, users, identities, service principals, and different resources. Let's take a deep dive on this. First, we're going to use the AZCLI to enumerate the current RBAC permissions of the low-privileged user account. And we discovered that that user has the reader permissions over the subscription. Next, we're going to use the AZCLI in order to find a group with owner permissions over the subscription, and we can discover the resource manager administrator group as the owner permission over the subscription. So now let's understand how we can assess permissions and role definitions over Azure Active Directory roles. In this case, we're using the UUID of a directory reader's role. And in order to know all the members that have this specific role, we added the /members in the end of the REST API request, and we can see that the low-privileged user has this specific role. And the last reconnaissance slide for today, I promise you, is the Azure Application Registration Graph App Roles Permissions. We need to have the application ID of the app that we want to enumerate, and we can see two different crucial parameters in the response. First one is the resource app ID, the source provider, which is in this case, it's the Microsoft Graph application ID. This is where the app role is taken from. And above that, we can see the ID, which is the actual group read-write role ID. So today, we're going to talk about 3 different attack vectors of privilege escalation or lateral movement techniques. The first one, the first scenario, will be from Azure Active Directory to the resource manager. The second scenario will be from the resource manager back to Azure Active Directory. And the third and the last one for the day will be from one on-prem machine back to Azure Active Directory and go back to a different on-prem machine. In the following demonstration, I will be using different kind of tools. I will be using the AZCLI, AZREST, and the HTTP proxy tool in order to demonstrate HTTP requests that are being sent both to the management and the Graph API. Before every attack scenario, we will spend the necessary conditions in order for this attack to take place. In this case, we need 3 different principles, as to explain again. The first one is an Azure AD user account. Second will be an Azure AD application with one of the following graph app role permissions. And lastly, an Azure AD group with elevated resource manager RBAC permissions. Let's start the attack. So, we are starting with an attacker that compromises a user account, then starts the reconnaissance phase in order to better understand his current permissions and ownerships. It then finds that this specific user account is an owner of a specific permission. Since he has the owner permissions, he can now add an application secret to that password and authenticate on its behalf. He then abuses the application permission in order to add himself to elevated group with elevated permissions. And since these permissions are inherited to that specific user, he can now compromise all over the subscription, meaning he can gain full control over all the resources in that subscription. Let's see how it's done. First, the attacker needs to enumerate the owners of this specific application by using the app ID of the application that he wants to enumerate. and discovers that the compromised user account, the low privileged user, is the owner of that permission. Next, it needs to list the current application permissions and discovers that this application has the group read-write-all permissions. In order to better understand what this means, it then took the AppRole ID of this specific group read-write-all and discovered that this allows them to update group properties and group memberships. This is great for the attacker. A compromised application with one of the following permissions will allow the attacker to add a member or a owner to any non-assignable Azure AD group within the Azure tenant. That's great. So the attacker then uses the ownership of the application to add a new application password. And then he uses the newly created credentials to authenticate on behalf of the service principal which is associated to that application. Great. So now what? The attacker needs to find an elevated group, a group with elevated permissions. So he runs the following HDCLI query to search for a group with owner permissions over the subscription, and he finds the resource manager administrator group as the owner permission on the subscription. Meaning, this will be the objective of the attacker. Then the attacker enumerates the current owners of that specific group and discovers that only the admin resource account is the owner of that group. Okay. The attacker then uses the group ID that he wants to add the owner to and the low privileged user account in order to add the low privileged user account user ID in order to add this specific account as an owner of that group. It then verifies the specific group owners and discovers that it was successfully added as an owner of that group. And since that group has the owner permissions on the subscription, it automatically inherits the permissions and can now compromise all the subscription and all the different resources in that subscription. Cool. Second attack scenario. From the resource manager to Azure Active Directory. We are now starting with an attacker that compromises a user account. He then starts to do a reconnaissance phase and discovers that that compromised account has permission over the Azure Function App service. He can then update the function code and put a malicious code in it. It then uses the malicious code in order to obtain the current access token, which is which are related to the managed identity that is attached to that function. In this case, it's the application administrator role. Since he has the application administrator role, he can add a password to any Azure AD application within the AD tenant. He then recons on the application permissions and discovers that the application has the specific drive permission, OneDrive permissions, that will allow him to read and even write to every OneDrive ID within the Azure AD tenant. So, for this scenario, we need the following conditions. First, we need an Azure AD user with the following Azure Resource Manager RBAC permissions. Then, we need an Azure Function App application with an attached managed identity that has the application administrator role. And lastly, we need the Azure AD application with any of the following graph app roles permissions. So, the attacker compromises the user account. In this case, it's the function update user, and lists his current permission. He then discovers that this account has the custom role definition called update function app. It then enumerates that update function app in order to discover its current permission, and discovers that the permissions are related to the function app service. So, what is Azure Function App? Basically, Azure Function is a serverless solution that allows you to write less code, maintain less infrastructure, and saves on costs. Basically, it's a serverless solution. Let's give a brief overview about the Azure Function App architecture. Every Function App has its own site. It can also hold multiple sites, which means a serverless website. Within every site, there is the runtime stack, which is the actual programming language. It can hold Java, Python, Node.js, and more. Within every site, you have the actual functions which run that code behind the scenes. Every site can work on both the operating systems Windows and Linux. Okay, so the attacker needs to now find a potential function app within the subscription and discovers the function app XM site. It then lists all the functions within the function app XM site and discovers two crucial parameters. The first one is the invoke URL template, which is the HTTP API access of that function app. Secondly, it needs the script href, which is the path to the source code of that function. Corey? He will need this specific information in later steps. Azure Functions offers 3 levels of authorization: anonymous, no key is required; function, the function app key or specific key is required; and admin, the master key is required. The attacker then enumerates the current keys of this specific function app and discovers the master key. The master key also provides access to all functions within the function app and administrative access to the runtime REST API. So, okay, what does it mean? The attacker sends an HTTP GET request with the obtained information. First, the X functions key header with the master key, and secondly, the path to the source code of that function, which is the index.js file. It then discovers the source code of the application, but unfortunately, it can't see any sensitive information within the code, and it doesn't have any potential vulnerabilities that it can exploit. So, it needs to find a different way to bypass that. It then uses a put HTTP request with the same content as before, and adds in the body of the request the eval function. It then checks again the current function's code as it did before and discovers that the eval function was successfully embedded within the function code. So now what? The attacker needs to find a way to enumerate the Azure Sites environment. He uses the process global object in order to concatenate 3 different methods. The process.platform, which will give him the operating system architecture, which is Windows 32-bit. The Node.js process title, which is the current execution of the process. And lastly, the process.cwd, which is the location of the specific execution. That's great. So we know it's a Windows machine, and you know how to exploit it. In order to do that, the attacker can use 2 different Node.js modules, the file system module and the child process module. Those modules will allow him to execute, read, and write files within the operating system. So, the attacker executes the child process exec method and execute a script, a Python script, and appends the data of that script to a separate text file, test.txt. It then uses the file system method, the read file sync, in order to create the content of that file. And it can now access the access token of the managed identity, which in this case is the application administrator role. It then uses the application administrator role access token as the authorization header in order to add a new secret to that application, as you can see in the server response. Okay, great. So it now enumerates the current OneDrive application and discovers the following graph APOL permissions. A compromised application with the following permissions will allow the attacker to gain and discover every drive account. And within every drive account, it will be able to read every file and folder within the drive ID and even modify those files. Microsoft Cloud Storage OneDrive is a Microsoft Cloud Storage service which allows users to upload files and access them from different devices. For every drive account, there is a unique drive ID. And for every file or a folder within that drive account, there's the drive items ID. Let's start attacking OneDrive. First, the attacker lists user account drives and discovers the following drive ID. It then uses the specific drive ID in order to search for specific keys with sensitive information. In this case, it searched for files with the content keys in it. It discovered the keys to the kingdom.txt file and that file's drive item ID. Okay, so great, what now? The attacker then used the obtained information, which is the user's drive ID, and the file drive item ID, and outputs the content of the file to his local drive. He then exported the content of that file and discovered the clear text password of a domain admin account. Great. So, the last attack scenario for today. From one on-prem machine to another on-prem machine. So, the attacker compromised a Windows machine. And in this specific machine, the victim regularly uses the Azure CLI in order to authenticate to Azure. It then harvests the access token of this specific user and discovers that specific user has the owner permission over an application, as we discussed in the first scenario. Since he has the owner permission, we can now add a new application password to that application and then use it to abuse the application permissions. In this case, it's a different permissions that are related to Intune. In this attack scenario, we will need the following conditions. We will need an on-prem machine that is being used for Azure authentication, either by AZ-CLI or Azure PowerShell module. We will need a user account with owner permission on the Azure application. And lastly, an Azure AD application with the following Intune permissions. So, Azure Access Tokens. Access tokens are used to call protected web API and to perform authentication and authorization on different environments. The refresh token in this case is used when the access token or the refresh token expires, and the default expiration of this refresh token is 90 days and is longer than the access token itself. So, when the victim authenticates using Azure CLI to Azure, a folder called .azure is created within the profiles, the victim profiles directory, and the access token and the refresh token are being saved within the access tokens .json file. Great. This is an example of a content of the access token and the refresh token that are saved within that file. In addition, when a user authenticates using a service principal and a secret, it will be also added to that file in clear text. Since the user has the owner permissions, as we talked before, he can now add an application password to a specific application that he wants. Then the attacker enumerates the current application permissions and discovers the following graph app role permissions. A compromised application with one of the following permissions will allow the attacker to create a policy and assign it to a group of devices. In this case, we're going to abuse it and we will use it to execute code on different devices. So, first the attacker needs to enumerate different devices within the Azure AD tenant to better understand and to adjust the payload of the operating system that he's going to attack. In this case, he's going to choose the Windows machine, and this will be the attacker's objective. It then uses the following post request with the script content, which is base64 encoded payload, to create a user and to add it as a local administrator group on the victim's machine. It then collects the script ID from the server response, since he will need it in the next steps. As you can see in the URL and the body of the request, we are using the script ID from the previous slide, and we assign it to a group of devices. In this case, we have a special group ID, which is basically all the devices within the Azure AD tenant. When the script executes on the victim's machine, we can see that it creates a folder with the script ID content. In addition, he adds the result key within that folder, which is saying if the commands were successfully executed or not. Since the attacker was able to successfully execute that script, it can now authenticate to the Windows victim machine as an elevated user and can gain full control over that machine. That's all for today regarding the scenarios. Let's talk about best practices. As security professionals, we want to be able to detect any hacking intrusion or attempts in order to better protect our clients' cloud environment. So, in this case, we can gather a couple of logs. First log will be the activity logs. The activity logs is referred to any subscription level events. For example, if a machine was restarted or modified. And in addition, we can use the Azure AD tenant logs that can give us information about specific sign-in attempts, whether if it's a user, an identity, or it's a service principal. In addition, we have the network, resource, DNS, and application logs that can help us to better detect those kind of attacks. Let's talk about the least privilege concept. The least privilege concept refers to an information security concept in which a user is given the minimum levels of access or permission needed to perform its job functions. As Stu said before in the beginning of the lecture, we can use the Azure Resource Manager RBAC permission in order to enforce the least privilege concept. For example, we can use custom roles and not built-in roles, and we can control the specific definitions of actions that a user will be able to do on a specific resource. In addition, we always want to use the whitelist approach and not the blacklist approach. And the last thing is, we can limit the role assignment scope. Instead of using all the subscription, we can use a specific resource group, for example. Next, we have the privileged identity management, which is a service in Azure Active Directory that enables you to manage, control, and monitor access to important resources in your organization. For example, it can provide just-in-time privileged access to Azure AD and Azure resources. It can assign time-bound access to resources using start and end dates. It can require approval to activate privileged roles, and it can enforce role activation using MFA with it. In addition, there are a lot more features in it. Let's talk about administrative units, which is kind of different and is not specifically to security. It's a unit, an Azure AD resource that can be a container for other Azure AD resources. It can contain only users and groups, but you can use it to restrict permission in a specific role to any portion of your organization that you define. Let's see an example. By default, an helpdesk administrator role has the ability to reset every other helpdesk administrator users or non-administrator users within the old tenant. By using administrative units, you can use the specific role in order to limit the scope of the user accounts that you can reset their passwords. Azure Active Directory Identity Protection is a tool that allows the organization to accomplish 3 key tasks. First is to automate the detection and remediation of specific identity risk. You can use it to investigate risk in your portal, and to export risk detection to your own SIEM. And the last one for today, regarding the best practices, I know it's boring, but we have to do it, is the conditional access policies, which they are at the simplest if and then statements. If a user wants to access a resource, then they must complete an action. For example, if a payroll manager wants to access the payroll application, she needs to use the MFA in order to access the content. That's it regarding the best mitigation, the best practices. Now Tzur will explain about the XM GOAT.
Thank you, Bill. Today we are releasing XM GOAT, which is a very nice photo that you can use in your Twitter profiles. No, I'm just kidding. It's an open source tool that consists of different scenarios being built with Terraform. Each scenario represents a different attack vector that you can use in order to learn how to exploit different misconfiguration in the Azure environment itself. Currently, we created 3 scenarios, but during the time we will continue to add, and with the help of the community, we can manage to have a large scenario repository. Let's see the scenarios. The first scenario is named Compromise Sensitive Storage Account Container. Our bridge point will be a specific user. We will start with him. When we will do the reconnaissance phase, we will see that the user have ownership on a specific application. Because of that, he can reset the password of that application as Bill showed you. Then, we will understand that the application have the permissions to execute commands on virtual machines managed on the resource manager. In addition, one of those virtual machines have an attached identity, which we can request and gain access to. the identity have the permissions to read sensitive information from a storage account. The next scenario is compromise the subscription. Our initial breach point is a service account, and our critical asset, our goal, is to compromise all the subscription. When we perform the reconnaissance phase, we see that the service principal have permissions to read secrets from the key vault. One of those secrets is the credentials of a specific user. Then we can authenticate as that user, and we identify that the user have the permissions to modify role assignments. Because of that, he can elevate his privileges with the owner role definition, and by that compromising all the subscription. The last scenario is compromising all the tenant, which is an account takeover. Our critical asset is the old tenant. This is our goal. We start with a specific user, and when performing the recon phase, we see that the user have access to a specific function app, and they also have the ability to update the function app code. Then we are going to exfiltrate the attached identity and the permissions related to her. We see that the identity have an application administrator role definition inside Azure Active Directory, and because of that, we can reset the password of all the application in the tenant itself. During the recon phase, we identified a specific service principal that have the global administrator role definition attached to it, which means that if we will reset the password for that service principal, we will take over all the account. So now it's up to you to understand how to exploit those misconfigurations. Thank you very much. If you have any questions, you can ask us.